Hi guys, Dr. Justin Southey here doing some of your tutorial assignment problems. We're asked here to use equation 7 to find some partial derivatives. Now equation 7 says that if you've got some function in three variables x, y, z is equal to 0, then the partial derivative of z, for example, with respect to x is simply equal to minus the the partial derivative with respect to x divided by this big F with the partial derivative with respect to z. Okay, note the minus sign and note also that the x goes to the top and the z goes to the bottom. But it's basically as simple as that. It's a really nice, easy way to work out implicit derivative. So first thing we need to do is we need to get this all into a form something is equal to 0. Well, that's very, very simple. We just put x minus z minus the arctan of yz is equal to 0. Now what we need to do is we want to find partial derivative with respect to x of z, and that's equal to, you've got it over there, f subscript x over f subscript z, and now we just need to work out those two over there. So the partial derivative of this with respect to x, treat z and y as a constant. We're going to get the partial derivative of x is 1 minus, treat this as a constant, that derivative with respect to x is 0. This now, interestingly, there's no x's here, so this in fact is also a constant, because that's a constant and the arctan of a constant is a constant. So the derivative of this whole function here with respect to x is simply 0, so our entire numerator is just 1. And we're going to divide that, don't forget the minus sign, we're going to divide that by this thing differentiated with respect to z. Okay, now the x disappears to 0. Differentiate minus z with respect to z and you get minus 1. Differentiate this with respect to z and you get minus, now the derivative of arctan, which is the outer function, is going to be 1 over 1 plus the argument squared, so yz squared, multiplied by the derivative of the inner function, again with respect to x. Y is a constant, so the derivative of that is simply y. Okay, we're pretty much done. We do need to do a little bit of simplification here. We've got a fraction over there. We can rewrite this as 1 divided by, let's multiply through by 1 plus yz squared. So we're going to get minus 1 minus yz squared, that's when we multiply by there, minus that y, all divided by 1 plus yz squared. Now we've got a, don't forget the minus sign in front here, now we've got 1 over a fraction, so we can just flip the fraction on its head. We can also multiply this minus through, all of these are going to become positive, and we end up with 1 plus yz squared all over 1 plus yz squared minus y. And that's now the partial derivative of z with respect to x. Really nice and easy. We're also asked to find partial of z with respect to y, so let's do that very quickly. We've got the partial of z with respect to y is equal to minus f subscript y over f subscript z. And again, we're just going to differentiate this thing with respect to now y and with respect to z. When we differentiate with respect to y, well, both of these disappear, but in our numerator we have the derivative of arctan yz with respect to y. That's going to be 1 over 1 plus yz squared, that's the derivative of arctan, multiplied by the derivative of the inner function with respect to y is going to be z. And of course our denominator is going to look exactly the same as it did before. We're going to have minus 1 minus 1 over 1 plus y z squared times y. Again, let's multiply through, simplify things out a bit. Well, our numerator now becomes z over 1 plus yz squared. This is just a little bit of algebra. This becomes minus 1 minus yz squared minus y over 1 plus yz squared. Of course, we've also got the minus in front, which again is going to multiply through and make all of these positive. And we're dividing by this fraction here, so we could multiply by its reciprocal. Then we've got the numerator, and this is the same as the denominator in that, and this cancels down very nicely to z over 1 plus yz squared plus y.